Or this.
Okay, so let's go through the discussion points first. So Alex will go,
sure,
and then hers, and then.
So one of the criticisms, or I mean, it's not a criticism that's in the literature. Actually, it's pretty hard to find criticism of LDA in the literature for obvious reasons. But it doesn't really. There's a sweet spot, or there's a certain characteristic length of documents for which it actually works. It doesn't really work for like super short documents, like query strings, if you're thinking information retrieval, which is primarily the use case a lot of people put it to. And it doesn't really work for super long documents either, which is a shortcoming with the overall framework, because if you're building something up as being based on Bayesian foundations, and people have to actually like do pre-processing, like stitching together a bunch of short documents or splitting apart longer documents, then that kind of secret sauce basically means that that whole build-up, or that whole Bayesian framework, was not really kind of good enough in the first place. The other problem, I like to, in our discussion, I kind of alluded to the poop emoji problem.
Yes.
I'm not going to name names, but there's a certain startup in Toronto. They were using this LDA for classifying tweet-like comments, and when you actually look at the posterior modes, like the most common words for some topics, you get a lot of clapping hands emojis or poop emojis, which basically means that a lot of kind of fluffy words are quite likely to become representative, or to become highly weighted in the distributions that you're going to get in your posteriors. I'm gonna omit some of the points, because it's kind of like, whatever criticism applies to unsupervised learning applies to LDA as well. So I mean, that doesn't really need explanation. Perplexity. So the general problem with perplexity is not a normalized metric. So you can know when something converges or if it's completely diverging, but you wouldn't be able to compare and contrast. You can't say, well, this is a good model or this is a bad model, because past the point of convergence, there's no absolute measure of. It's not a percentage point metric. It's there's not much to make it concrete, to make it interpretable across models, across data sets. And I have a meta criticism as well, if I can add that. The meta criticism around LDA is it's applied in a cargo cult manner. Like a lot of people, if you look up digital humanities, a lot of people that are working on scientific like webs of citation or stylometrics or digital humanities in general, just apply it without even understanding it, and they kind of come up with very bogus conclusions. So, and it's kind of spreading to the business world as well nowadays. Everybody's like, oh yeah, we're going to do an LDA. Your customer support tickets are going to be neatly and cleanly organized into a bunch of topics. You can cut down on your human-intensive processing. And when people make those kinds of promises and don't deliver because there is that fundamental lack of understanding, obviously it's generally bad for the field as a whole, and just makes us look bad. So yeah.
Great. So do I have to comment on this? I do, right?
You don't have to comment.
So I'll actually share my experience with the topic model stuff. So basically, I got like a bunch of like chat logs to start with, and then so what Alex said was correct. So for chat logs, there are short text. So you need to do a lot of data cleaning. So I have a util function just for cleaning the text. Because think about that, you have a data set that mixed with like HTML, which is pretty easy. Like you have HTML, and then you have like emoji, whatever, and then like you have a lot of like exclamation mark, like you have like continuously, and then to emphasize how angry they are, whatever. So that kind of text without cleaning, it actually ruin up all the like probability, whatever. So the topic that you're getting is actually nonsense. It doesn't make any sense. So a lot of data cleaning is required. And then like even when the topic you receive, if you don't have the pre-knowledge about the data set you're looking at, you still don't know what that is. So basically, for example, I'm actually processing like banking data. A lot of stuff is like insurance, but they have a very, very particular name. So as a human, you might think, oh, is it like something that like a typo? No, it's not a typo. It's actually a product name. So you need to actually think about this. And also the same problem, for example, I'm processing like RBC, CIBC. CIBC, RBC will across different topics. It doesn't mean anything. So you kind of have to ingest your own knowledge that if I see this word, I have to filter it as a background word. So that process of cleaning that background was still needed. So it's like in terms of data cleaning and then like post-processing. So just getting the words also doesn't help human understand the intent. So topic models tells you which words is most important, but it doesn't tell you like which is that an intent. So because people most likely they want to know the topic because they want to know the intention. Why is this topic composed? Not just like, okay, I see cats, I see like birds, house in this topic. It doesn't help anything, right? So you want to know the intention or what is really discussed.
Yeah.
Then you have to do a lot of
stance.
Yeah, you need a lot of post-processing after that to actually extract the knowledge. So it's just like a middle layer to me. Yeah.
So to add to all this, I totally concur with both of them. So I recently used LDA in 2 cases. One was, like they said, sentiment analysis, and I had these reviews, and I wanted to detect the sentiments, and apart from that, I wanted to, like, they were customer reviews, so I wanted to find out what, like, if they have given a negative rating, so what were those exact topics that they found problematic? Like, what was their reason for, rating 1 or 2, which was reflected through their, feedback, specific feedback. And first thing is, of course, the data cleaning part. And when we use LDA, of course, the kind of topics that it comes up with, it would be nonsensical. But if you have a more formalized text, I used it on a formalized text, it gave me better topic distributions, topics altogether. One solution for...
What do you mean by formalized?
Formalized as in, research papers, and, you have reports and all, news texts and all. I found this interesting, that if you really want to find out, for reviews and all, the sentiment analysis, and if you want to find out the exact problems, there's one more way of, circumventing this problem. Instead of using LDA, like I used a dependency parsing, and I kind of, was able to find out those phrases associated with different sentiments and all. So that could be one way or one place where you could look for when it comes to looking for topics, especially when it comes to reviews and all, customer reviews. So dependency parsing could be used. That's one solution.
So when you say dependency parsing and sentiment analysis, you're talking about hierarchical sentiment analysis, right?
Yeah.
Because sentiment can be limited to a word. A word can be positive sentiment, negative sentiment,
yeah.
But when it goes up to the phrasal
Yes,
level,
exactly.
they may mean a difference. So that's
Yeah.
a common approach in sentiment analysis to sort of restrict it not to words and phrases.
Yes, especially when you're looking for,
Because dependency parsing,
yeah.
just as an input information for people to
have. You have everything in front of you, like you have an object, you have an action verb, and you have the subject. And you can actually find out, you could correlate it with the sentiment, the kind of score that they have given, and you can try to find out, automate the process of finding out what the problems with your products are.
What is perplexity?
Yeah.
So perplexity is a measure of how chaotic things are. I think it's 2 to the power of entropy.
2 to the power of entropy, yeah.
Yeah.
Yeah, that's true, but in this context, like what does that mean?
So I think then your question is for Alex, because he mentioned perplexity.
Yeah. So perplexity in this context means any statistical model, when you apply it to whatever sort of data that you have, it'll explain some of the variation in the data. Some of the variation remains unexplained. Now that variation that remains unexplained, if you're doing a linear regression, for example, you say, my R-squared score is 0.75, which means that 25% of the variation remains unexplained even after
Alex,
the model.
could you speak?
Yeah, even after you apply the model. Now, in a certain sense, that's only for continuously changing variables, output variables, or dependent variables. When you're talking about sequence modeling problems or discrete collections like sentences in language or documents in a corpus, you're talking about, given a topic distribution, given the same proportions, the same topics, the same word distributions over topics, how many, given a characteristic of a certain document according to this statistical model, how many actual documents in corpus I have, in a certain sense. This is simplifying it pretty much, but it's kind of a measure of that count. On average, you succeed in capturing 50 documents in one bucket in a certain sense. If your perplexity is 50, it means that for any set of...
Does it have, let's ask, does it have anything to do with the standard deviation of the topic distribution?
It's not a standard deviation. It's a measure of dispersive tendency. In that sense, it's very similar, but it's also very different because it has the dimension of a count in a certain sense. It's not a...
So is it like at the level of the corpus? So it's like so the corpus is a collection of documents. So how well you can actually bucket or classify documents into?
Ideally, yeah, exactly. Ideally, your statistical model should completely explain your corpus. So each document would be uniquely kind of modeled down to the individual features, or if it's a sequence of words, down to the words. This perplexity is basically a measure of how far away from that you are in terms of how many things are still not distinguishable by your model that are different documents in your corpus,
so where
roughly.
would you see the problem would be if you're, if you cannot just bucket certain documents? Is it more of because of the corpus, those documents are too dispersed, or?
So this is the thing. So in a certain sense, I mean, there's an unstated assumption that if you are doing the analysis on a corpus, to the point that she made, if it's a knowledge base for an insurance company or something, you don't have redundancy in documents. Each document is responding to a different information retrieval or information fulfillment need. So these documents should be non-overlapping. Ideally, if you're statistically modeling it, you should be able to identify different documents. They're not one and the same. So any failure by your model to distinguish two documents would be considered a failure of the modeling process. So if you have to bucket more than one document through that how you parameterize the model, basically that is considered a failure.
Right. Yeah, because I think when you set the parameter of the diversity distribution, so if you actually the distribution is more at the center, then it means that this document contains more evenly about all the topics, right? Yes. So then, if in this case, then your the topics in your document is more spread out, then it's harder to bucket this document, right? Because then you don't really because the weight will be more evenly distributed in the topics. So in this case, then would it be? Yeah, so would it be a problem?
That is a problem with Bayesian statistics in general. Jokingly, people say that you take your priors out of your posterior. So it's completely subjective. There's no method to the madness. So if your prior is super non-informative, too bad. I can help you with that. If that's a limitation you're facing, yeah.
Okay, let's move. Great points. Let's move on. Zen, you had a question, and I stopped you.
Yeah. So 2 questions. The first one, all of you guys mentioned data cleansing as being super important. So are there any best practices with LDA specifically with regards to data cleansing? Because if you're doing parts of speech tagging or anything like that, you can't remove stop words because there's formula dependency trees, for example. So is there any kind of certain best practices or rules of thumb, you want to get rid of punctuation, you're not want to get rid of punctuation?
So I want to add stuff in. You tell me if you disagree. So I think the one thing that wasn't mentioned, you usually want to also remove stop words, right? Because they also mess up with your frequencies. So stop words, punctuations, I don't know, emojis sometimes are actually informative if you're...
They are informative in tweets or short, yeah.
So I think short answer, it definitely depends on your application. And in some applications you may want to keep them, but more often than not you want to get rid of stop words and irregularity.
And the second question I had was, if I actually want to use this on some review data, for example, so if I train my LDA across a whole bunch of different documents, and I now want to use it to understand what people are talking about across all my reviews, so do I then just concatenate all the reviews together and run the topic model at inference on a single document?
Yes.
Is that the
You
approach?
run the inference only.
Okay.
Yes.
So concatenate everything together and then run inference?
Concatenate everything together, you mean? Like,
Yeah,
just
so
you
like-
still run by document base and then you
You
inference
review,
it.
every review would be one document.
Yeah.
Right, and I want to now understand what are the topics across all my reviews. So
Exactly.
Yes, then you
so
do-
that's
yeah.
what that's what even your airline industry, your hospitality industry, it does that the same thing. Takes the review, cleanses it to extent possible, and then it uses LDA to find out those topics. And here, topics are indicative of what? Your sentiments. Your what are you so happy about, or what are you so so negative about.
Okay,
So that's what you're
just so
supposed
I'm totally clear, I think I misunderstood initially. So once we train the LDA, I don't have to run inference on it I can just look at what my topics are
Exactly.
and then get an understanding of what I trained it on.
Exactly.
What's the size of the beta matrix? Is it given by the document size?
It depends on the vocab size you have and the topic you have, the topic number you selected. So
Yeah,
it's-
that's what is confusing me. Like, is vocabulary size vocabulary of English language, or is it the
Oh, the
word
vocabulary
size
of the words in your corpus.
in the documents,
Yes.
right?
So-
So yes.
Usually a good practice, if I'm not interrupting you, a good practice is to also cut down your vocabulary size because that makes your matrix really sparse.
Smaller.
Usually people have a frequency threshold. If it's under like 3 times, happened on 3 times, you want to get rid of it,
Yes.
and that saves you like a lot of space.
So in a way, if I have a document with, let's say, bunch of 1,000 words, you take out all your stop words, you clean, and whatever number of words you are left with, then you do your thresholding, and that's basically kind of gives you an estimate of the beta matrix.
And thresholding and also lemmatization, that's very
Yeah.
important. So that you standardize it, canonicalize it, so that it's not that like you frequently come across words that are not part of your vocabulary.
So lemmatization is a process. If you have going, then go would be your lemma,
Yeah.
for example.
Yeah.
Can you summarize what are some of the hyperparameters in this model? So you have
Summarize
alpha, and you have the number of topics you choose from.
Which one? Where do I
For
start?
LDA.
For LDA?
Yes.
This one?
Yes.
Summarize.
So you have alpha.
Yeah.
And you have
Beta.
So for beta, you have a number of topics that
Yeah.
you can choose from. Okay.
Yes.
Interesting. Is that it? Like alpha and how many topics?
Alpha and no, it's theta and beta that you want to be. This is the end product you're looking for.
He's asking about hyperparameter.
Oh, hyperparameter is actually alpha.
Hyperparameter.
Yeah,
And-
alpha and
of
yeah,
that is-
and yes.
Isn't
yes,
there
the
some
duration.
more? Isn't there some more because you optimize? You do the optimization in that algorithm. There must be a few more, right?
There are like random variables to start with, like alpha, beta,
Latent,
and then they will have
latent
latent.
variables.
You have latent variable as well.
So-
Latent is Z.
Did you say beta was your number of topics, or did I?
Yeah,
hear
no,
was-
beta is actually the topic.
matrix.
Yeah, the matrix.
the matrix.
Yeah, this one. All the way back here. This.
Sure. So basically, your vocabulary that
Yes,
determines
yeah.
the number of columns.
Yeah.
And then alpha was your Dirichlet part.
Alpha, yes, that's correct.
Is this a convex method? Like, will it always give the same answer if you keep running it?
If
Will
you-
it give the same?
No. Because it again depends on the initialization and this the variational inference and all. Some of the algorithms they use EM to do that. So initialization again depends on your initialization. What you get.
So you use
Yeah.
EM for optimization. Is that
Yes, that's one of the methods.
Yeah, and you can use skip sampling. You
Yes,
can use
skip
CMC. It's just like you have to approximate it. You just cannot calculate it. And,
Sure.
Yeah.
Yeah.
But you can do all these methods
Yeah.
alternatively.
I remember when I look at like Dr. Bly's presentation, he actually have a list of like the technology you can approximate the posterior.
Exactly.
But if you keep all that fixed, still what you get at the end, can it change? Like, is what I mean is that is it like a method which always gives you the same probabilities for all the topics, or it can change depending on how many the run, basically how you see the run?
It should converge.
It should, yeah, it should converge.
But-
Like they look
Yeah.
at the elbow function and that should
Yeah.
converge. But you're right, the probabilities might be different.
But it could
That's
be
right.
is like if you want wrong once, the first topic is this, and the second topic is this, and you on the second time they swap. But you still kind of converge at the same thing overall.
Yeah, so
Depending on your
you're actually
interpretation.
looking at the point of convergence of the elbow there,
Okay.
the evidence lower bound. But the thing is that
Yeah.
there is a lot of
Possibility.
possibility that the topics that you get once might not be the same.
Okay.
If I understand correctly, it's a little bit similar to like deep learning model. You will have like some like local minimum, but for these, it's actually the local maximum. It's actually the opposite.
Just
Yeah.
to clarify, so when we are talking about convergence here, we are talking about the estimation of the probabilities that's converging to certain
Exactly.
things,
So,
right?
in that particular
Which one?
slide where you
The-
talk about the Q, a
Oh,
more
okay.
simplistic way
Yeah.
of defining your probability distribution.
Right.
I
That
actually don't have
is
to-
where
I don't
you
have
have
to-
this gamma and phi here. So that gamma and phi could be set differently, right? And that's where the variation comes in, because you cannot do the absolute. You can't come up with the absolute probability p of let's say z given a particular w. That's where the problem comes. That's why we start estimating it using a simpler model, and that's where that kind of uncertainty comes into picture.
So to his question then, like, because this is the generative model, right? So it's like estimating a posterior probability distribution. So in general, does all generative model all produce consistent result in each different run? Is that the case? To your question, I don't know.
I have no idea.
So because that's generally that question, right? So like in this
So
case,
so like for neural nets, I can say that the answer is no.
Yeah.
Because depending on how you initialize them, you may end up in different parts of the different regime of your curvature, right? Okay, I'm gonna leave like 2 minutes for people who haven't asked any questions, and then I have a question.
Yeah, so just going back to your first discussion about having to pre-process and clean data before running LA. I'm just thinking about that and what that actually means in terms of like the theoretical model. And I'm just wondering something, if this is the case, and I want your thoughts on it. So I'm wondering if what you're actually doing is something like a review data or some like a tweet or something like that. When you clean it up, when you have your mutual function, when you clean it up, what you're actually doing is making that body of text, like the words that are in it, look more similar to the model that we adopted for the LDA, where each word is very discrete, and like you don't have these emojis and like these exclamation marks and all of that stuff. What you're doing with the cleaning is actually making the data look more like your pre-assumptions and how it actually came up with LDA, and that's why it works better. Would you agree with that, or?
Yeah, I think he's
Yeah.
saying that
Yes,
if you,
I understand. Yeah. The question is that the cleaning part is making the data more have the similar distribution.
The similar
Yeah,
structure
and then,
to
and then
the
you're
problem.
with
Yeah.
your prior, so it works better.
Yeah.
I'm not coming from math background, so I won't be able to actually answer this question. Maybe I'll let Renya explain this.
Yeah, I think your point is right. When we do too much of something,
Yeah.
especially cleaning,
Yeah.
it kind of biases your
Exactly,
your
yeah.
data set. and you're not able to get those insights that you would get, and that is characteristic of that data set. Like he said, people do this, they remove punctuation, they remove even the emojis and all present in the review data. But that's very important because that itself is expressing some sentiment of your customer.
And it seems like how we came to LDA from the uniform and then PLSI, it sort of assumes this very structured, nicely written, like a book sort of body of text, but what we have now on the internet is not that. It's something else. It is like sometimes very heuristic and it doesn't really have the same sentence structure. So
it's not capable of understanding your sarcasm. It's not capable of understanding your very complex expressions present in the reviews and all. But then that's why I said, when you use the same method on the kind of documents that it is made for. For example, research papers or reports and all.
So it appears to it better.
Exactly.
A quick case in point. Social media analytics in general is the toughest service. There is a book by our lab at U Ottawa is the expert in this area. Darna Inkpen, you can find her book online. Inkpen, yes. She has an entire book on social media analysis, and it has quite a few challenges. The utterances are very short, highly irregular. You get rid of noise, you get rid of information too, so you have to really study well. Which sort of leads to my question and maybe some of the insights I'd like to share. So they didn't directly at this paper. They didn't compare with LSA, but that seems something that seems very applicable because LSA's latent semantic analysis have been used before to compare to sort of classify topics. And basically what it does, it generates latent representation per documents, which is again similar to what they have. Are you able to share some insights if you have seen elsewhere a comparison with LSA?
I actually, that's what I heard, but it doesn't, I've never done any a comparison myself. I heard that the result wasn't that different. But another thing is that when we are actually using the mixture model and then POSI, sometimes because they're actually modeled not like a distribution, they have a way to actually put another class called background. So they will model a lot of stop words there. So that kind of help cleaning up. So you probably don't need to do that much cleanup yourself. You just put all of the background words to whatever category you believe that is actually background words. So it helps you the topic model works better. But I've never seen someone use LDA model and being able to actually work with the background words. So I think that's why when the empirical result will show that they don't look much different.
Okay, I've seen I know of one line of research that was done in our lab. People used LSAs and LDAs on sentiment analysis, and the result with LDA was superior, significantly superior. I can refer you to that paper. So that's something that I've seen, and it kind of came in, I think, washed sort of over all the previous methods. The other thing about LSA that I want to put in is it's very computationally intensive because you have a huge matrix usually, and then you have to factorize the entire thing.
Yeah.
Some of that criticism I think also applies to LDA, but that was my comment. So one last question I ask, and then we can end it if you feel like. Could you walk me through the training versus inference over here? I know Zane sort of asked along those questions, but could you walk me through that?
Training versus inference.
Yeah.
So training is basically you have all the data, and then you actually have you start training. You want to get the approximate the posterior probability, and inference, I understand, it just basically said that I have this model, and then based on my theta and alpha, and I'll be able to get the z. That's my understanding. So it will tell me which one is the topic that I believe.
And so you have beta. So then if you want to apply it to a new corpus or collection of documents or a document, you already have a trained system and then you input all the variables, and then for each document, it's able to tell you what topics are in there.
Yeah, it will tell you one topic only. Yes, like across, like for example, I have 20. It will tell you which label it belongs to.
Good.
One last question related to what you mentioned. But what are the dates that kind of LDA came out and LSA came out, if you know?
I think so. LSA has been there for a long time,
Okay.
because as long as matrix factorization.
Okay.
LDA is pretty recent. I think it came out
2002 or 2003. This
Yeah,
paper is actually
2002 actually.
2002, because the one in machine learning, whatever journal, that was published in 2003. But then there's another paper before that, so I believe it's around 2001 and 2. Yeah.
So as a follow-up to that, with all these new stuff that's
that was
happening,
a follow-up to your last question.
all this new stuff that's happening in NLP, especially this year, like how do these deep learning techniques we're using now for supervised tasks, can we take this idea of like transfer learning and training on corpuses and then kind of bring that to these older techniques which are being used for like unsupervised purposes?
I can get a quick, if you like.
Yeah, now let's just.
I can get you a quick answer to that. So I think like the premise that deep learning brings a lot in to take advantage of that weren't just possible. So it's sort of pushing away Bayesian stats. I know Bayesian people's kind of they're gonna hate me online, but there is a lot of math that you have to do prior. And you have to study your problem carefully and then tackle it. With deep learning is that you're only dealing with hyperparameters, which ironically sometimes have to do some Bayesian stats on. But it sort of takes away a lot of the hassle of tuning a lot of parameters prior to this. So basically for sentiment analysis, like you can use RNNs, you can use CNNs, and it's much easier to train and converge.
So something like a topic model, which is an unsupervised problem, like can we still approach something like this with the stuff we're doing now?
I feel it's very similar, right? Essentially, you're looking for the latent variable
Right.
and then try to construct like the similarity from there. It's just like how you get that latent is very different.
I think the advantage that LDA has and don't have is usually that it's unsupervised, but then we have shallow embeddings and we have representation learning, which tackles sort of in parallel the same problem. All right, let's end the session. Thank the speaker and the experts.
Thank you.